Okay, in today's video we're going to look at the properties of hydrocarbons. First thing we need to do to be able to understand the properties of hydrocarbons is to be able to understand these keywords. So we've got boiling point, viscosity and flammability. And if we have a look at these, I'm just going to change the colour pen. So, boiling point. Well, boiling point is the temperature at which something becomes a gas from a liquid. So temperature, liquid becomes a gas. Now I'm sure most of you will have heard about boiling point before. Viscosity might be a new word to you. So viscosity is to do with how thick the material is. So is it thick and it doesn't pour very well, so it's a thick liquid, or is the viscosity quite runny and actually you can pour it? So a high viscosity means it's really thick, and a low viscosity means it's very runny. So it's how thick a liquid is. Flammability is how easily something burns. So if I were you, if you've not heard any of those words previously, and that's fine if you've not heard any of them, I would make a note of boiling point, of any of the ones that you haven't heard before, so whether it be boiling point, viscosity or flammability, and simply tell me the definition. You might want to add a little bit more detail or a diagram to remind yourself what that viscosity means. So you might want to talk about the fact that runny honey would be a low viscosity, whereas a thick honey would mean that it's a high viscosity, because it's all to do with how thick or how runny something is. Or you might want to talk about flammability and the fact that a really high flammable material means it burns very, very easily. So if you need to, pause the video and write out those keywords. Okay, so on the screen now I've just put methane and butane. So last time we drew out and we were learning about how the shortest chain hydrocarbons, or hydrocarbon with anything with just hydrogens and carbons chemically bonded together. And we looked at the smallest one being methane with just one carbon in it. And we went up to 4 carbons in a chain. Now you can get much bigger than that. You don't need to know the names of the ones that are bigger than just 4 hydrocarbons. But you need to be aware that you can get much, much bigger than that. And we're just going to use butane today, but you have to remember that this isn't the longest chain possible when we're doing the next activity. So say longer chain. And the properties of methane is that it's got a low boiling point, so actually it becomes a gas at a very, very low temperature. It's very, very runny when it is a liquid, because it's not, and it's moves very freely, and it's very flammable. So it burns at a low temperature. It burns very, very easily. So those 3 things are the properties of methane. Now, as you add each carbon, it changes and it becomes a higher boiling point. It becomes a higher viscosity, so it becomes a bit thicker. Each time you add that carbon, it's causing these properties to change. And this very flammable, it gets less and less flammable as you add more carbons. So with that in mind, I want you to have your this drawn in your book, or draw butane and tell me, based on the fact that every time you add a carbon, these properties are going to slightly change like I've just explained. I'd like you to tell me, do you think butane's boiling point will be higher or lower? Its viscosity, will it be higher or lower? And will the flammability, will it be more or less flammable as you go from methane to butane? So simply, what's going to happen to the boiling point? What's going to happen to the viscosity? What's going to happen to the flammability to butane compared to methane? Pause the video, have a go, and I'll go through the answers. So I hope you've written something for each of these. So low boiling point. Butane, there's more carbons. So like I said earlier, the more carbons, it means it's going to have a higher boiling point. So you need to know that it needs a higher temperature to become a gas. So it'll be a liquid for longer, higher boiling point. Let's move from viscosity over. Low viscosity here, it's going to have a higher viscosity, not the highest possible because we've got much longer hydrocarbons that we know of, but for this example it is a higher viscosity, and that means it's going to be thicker than our methane. Very flammable, less flammable. It's not as easy to burn butane as it is to burn methane. So the key idea is if you were able to remember what methane is and the fact that methane's got these properties, you know then that everything above methane has got higher boiling points, higher viscosity, and is less flammable. So you know methane is going to have the lowest boiling point of all the hydrocarbons, the lowest viscosity, so it's the most runny of the hydrocarbons, and also it's the most flammable. So from there on, each time you get more carbons from methane, it's going to have a higher boiling point, a higher viscosity, it's going to become thicker, and it's going to be less flammable. So how would this look in your exam? So I've got an exam question here that we're going to look at. So we've got some hydrocarbons, they've not named them, W, X, Y and Z. And it says, which of these hydrocarbons has the largest molecules? So that means that largest molecules bit, let's highlight it. Not very good highlights there, but this largest molecules, that means most carbons in the chain. So which one has the most carbons? Well, we've just said the more carbons you add, the higher the boiling point. So which one out of these boiling points has the highest? And it's this one. So you would say Z, and you don't need to give an explanation, it's not asked you why, but Z because it's got more carbons than methane, so it's going to have a higher boiling point. Or Z because it's got the highest boiling point. Simply Z will give you the mark. And which of these hydrocarbons ignites most easily? Now, if we've said that the largest molecule is Z because it's got the highest boiling point, and previously we said that the hydrocarbons that are most flammable, that ignite the most easily, are when you have the least amount of hydrocarbons, the least amount of carbons in the hydrocarbon chain. That means it's going to have the lowest boiling point. So for this example, it would be X. So just to go through that one again, which of these hydrocarbons ignites? That ignites means how flammable it is. So which one's the most flammable? Well, it's going to be the one with the smallest hydrocarbon, so it's going to be the one with the lowest boiling point, and minus 160 is lower than minus 40, so it's going to be X. I'd like you to have a go at this one for me, please. So it says some properties of hydrocarbons change as the size of molecules increase, and remember, size of molecules means number of hydrocarbons. Not number of hydrocarbons, sorry. Number of carbons in that hydrocarbon. Number of carbons. If I could spell. So number of carbons. Describe the trends in boiling point. So you've got boiling point and viscosity. So they're using the words we've looked at as the number of carbon atoms in the molecule increases. So I'm looking for a sentence explaining that what happens as we increase the number of carbon atoms, what happens to the boiling point, and what happens to the viscosity. If you need to, rewind back, listen to my explanation about what happens to properties of hydrocarbons, and have a go at this question.